Hello and welcome back. Today we're going to look at rational expressions, multiplying and dividing them. So remember, rational expressions are when we have polynomials in the denominator. So for the first example, we're just going to write equivalent expressions, meaning we want these expressions to be equal. So when I look at the numerator, well, there's a GCF. We always want to see if there's a GCF of x. I can factor out the x and we're left with x squared minus 5x minus 24. I can look at the denominator and there's also a GCF of x. So if I factor out the x, I'm left with x squared plus x minus 72. That is an equivalent expression to this. They both equal each other. So if I distribute the x on both the numerator and denominator, I'll get back to the original. Now you may remember we can also factor. So looking at the polynomial x squared minus 5x minus 24, remember we're looking for two numbers that add to make negative 5 and multiply to make negative 24. And that's going to be negative 8 and positive 3. And then in the denominator, we can also factor x squared plus x minus 72 because 8 times 9 makes 72. And then if I add them, well, we'll have to make one of them negative. So we'll make the 8 negative, so it's subtraction. So we're going to have x minus 8 and x plus 9. I had to make sure that bigger number was positive because we have a positive 1 here. So those are equivalent expressions. So what we would like to do is after we write equivalent expressions, we want to be able to simplify. So simplify means that we're going to reduce some of those common factors. So let's first consider this polynomial. So we have x squared plus 3x minus 10. Now remember, anything in the denominator cannot equal 0. Right? So that is going to be a restriction on the domain. So let me just first factor the top and the bottom. So this is going to be 2 minus x, 2 plus x. That's a difference of 2 squares. And then on the bottom, that's going to be x plus 5, x minus 2. So we know that for the domain, the denominator cannot equal 0. I wrote it again. Okay, so when I look at these numbers, these cannot equal 0. So x plus 5 cannot equal 0. X minus 2 can't equal 0. Because if we have 0, that means we're going to have to be dividing by 0. So if I put negative 5 in there, the bottom will equal 0, and we can't have that. And if I put in 2 for x, that also makes the denominator equal to 0. So those are two numbers for x that will not work. Right? We're going to have restrictions on the domain. So now we're going to simplify. And when we simplify, we want to look for common factors. And it's kind of hard to see, but 2 minus x and x minus 2 are very similar, right? So if I rewrite this 2 minus x as the negative, and I flip them around, right? So the x was negative, it's now positive. The 2 was positive, now it's negative. And I'm going to rewrite this 2 plus x into x plus 2. That's why we try to get in the habit of writing the variables first. All right, so that when we start to cancel and when we start to combine terms, we already have it in decreasing order of degree, right? So here we have two common factors. We have x minus 2, right? And so we know that this is going to be negative x, I'll put parentheses here because that negative was outside the parenthesis, over x plus 5. And if you want to put the negative out in front, you can do that too, x plus 5. But just remember that this picture, this expression doesn't capture that x can't equal 2. So we need to make sure we include that restriction. So we know that x can't equal negative 5 and x can't equal 2. Well, we can see the negative 5. That one didn't get canceled, but we did have to cancel out the x minus 2. So that's not readily apparent. So that's why I want to make sure I put that restriction in there. All right, let's go ahead and start multiplying these. So when we multiply rational expressions, we're going to multiply everything in the numerator first, and then in the denominator. So let me just write it on the bottom so we have some space. Okay, so here we have 2 times 3, which is just 6. We have an x here, so x to the 1, and 2 more, so we're going to have x to the 3rd and a y. Now let's combine everything in the denominator. So that's 4 times y, and then z squared. We have 2 of those z's. All right, and now we can start reducing. So looking at the numbers, well, we know 2 can go into 6 and 4. So 6 divided by 2 is 3. 4 divided by 2 is 2. I like using different colors because it helps us see it a little bit more clearly. And then look at the variables. The only variables that are in common are the y. They both have one y. So I'm going to cancel those out. And we're left with 3x cubed in the numerator and 2z squared in the denominator. So I just want to go back to this multiplication up here, and I multiplied in everything in the numerator and then everything in the denominator, but you don't necessarily have to. You can cancel terms too. So I have this 2 and a 4, right? You have the y and the y, and you can see you're left with 3x plus this x hanging out there. And then you have 2, putting this in order, and z squared, right? So regardless of which way you want to simplify, if you want to multiply everything in the numerator as I had done down here, or you want to just start reducing right away, if that's your prerogative. Whichever you like to do, just make sure that we try to put the number in front and then the variables. And make sure you always reduce those variables and numbers. All right, so now we're going to go back to polynomials, and here you can see we have something more complex. So the first step we always want to try to do is factor each as much as possible. We don't want to multiply everything in the denominator and everything in the numerator. So what we're going to do is rewrite this 5x over x plus 3. That's factored enough. We can't factor that anymore, right? And then let's look at the second fraction here, the second rational expression. X squared plus x minus 6. So that's going to factor into x plus 3, x minus 2. The denominator is going to factor into x plus 1 squared. So I'll just write that twice. And then looking at the third fraction here, this rational expression, we have an x squared plus an x. So x factors out. We're left with x plus 1. And then a 5 is a GCF, so I'm going to factor that x minus 2. So from here, you can actually start reducing. You do not need to multiply everything in the numerator. So what I like to do is just start from left to right. So do I have a 5 in the bottom? Yes, I do. That can cancel. All right, do I have an x? Just be careful, this is stuck together. All right, you cannot take away that x because it's stuck with that plus 3. So we have to only look for an x plus 3, and we do have that in the second fraction, x plus 3, x plus 3. And then when we look x minus 2, yes, we have another one in the denominator. You can only cancel one that's in the denominator and the numerator. And then x plus 1, x plus 1. All right, so I'm going to circle what's left in a different color. So we have an x here, an x here. So that's going to be x squared in the numerator. Everything else had reduced. And then we have the x plus 1 in the denominator. So that's going to reduce to x squared over x plus 1 in simplified form. So steps were factor first. We want to try to factor all of these, and then we reduce by canceling out common factors. All right, for this next one, it's very similar, except we have a polynomial. So what I like to do is make sure I write this over 1. Same idea, we're going to factor first. So on the first fraction, we have x plus 2. Well, that's just factored. And then this, well, that factors quite a bit. So that factors into x squared minus 4, x squared plus 4. And if you remember, this x squared plus 4 is prime, but this x squared minus 4 can factor into x plus 2, x minus 2. So that factored a little bit more. All right, and so that's good. Now I'm going to look at the second fraction. So from here, we have an x that factors out, and we have x squared plus 4x minus 12. So we're looking for two numbers that multiply to make negative 12 and add to make 4. So that's going to be 6 and negative 2. So this factors into x plus 6, x minus 2. And in that second fraction, you just had a 1 in the bottom. All right, so now we get to reduce. So we're looking for x plus 2, and we do have that. We're looking for an x minus 2. We have that. And then there's nothing else that'll cancel, so we're left with x times x plus 6 in the top over x squared plus 4 in the bottom. Remember, that doesn't factor anymore. For example 5, we're going to start dividing rational expressions, and it's very similar. So remember, if we're going to divide, it's the same as multiplying by the reciprocal. So I'm going to rewrite the first rational function. So x cubed plus 3x squared plus 3x plus 1 over 1 minus x squared. And then we're going to multiply by the reciprocal of the second fraction. So we have x squared plus 3x minus 4, which is in the denominator, now it's in the numerator, over x squared plus 5x plus 4. So we're flipping the second fraction upside down. We're finding that reciprocal. All right, so same steps here. We're going to factor. So this factors into x plus 1 cubed. So I'm just going to put this as x plus 1, x plus 1. And then the denominator, well, that factors into 1 minus x, 1 plus x. So you can start to see we have another opposite right there. And then in the second fraction, we have x, two numbers that multiply to make negative 4 and add to make 3. That's going to be x plus 4, x minus 1. And then two numbers that multiply to make 4 and add to make 5. That's going to be x plus 4, x plus 1. So you can see a lot of things are going to cancel. And right away, you can see this part right here. You may want to rewrite that. So this is x plus 1. And then we can rewrite this opposite here if we put a negative out front and flip this. So this will be x minus 1. All right, so again, what we did is multiplied by the negative to make the opposite. All right, so now we're going to cancel terms. So we have an x plus 1, right? We have another x plus 1 over here. We have, I just erased this, was x plus 1. And then we have, what else? Do we have an x plus 4? Yes. And we have an x minus 1. So looking at this, we only have an x minus 1 on the top. Trying to find a color I didn't use. So x plus 1 right here, that's the only one that's not canceled, and the negative, so don't forget. So it's really x plus 1 over negative 1, or you could say negative x plus 1, which is also negative x minus 1, because everything else canceled out. All right, so let's look at this last word problem, and we're going to actually bring in some geometric concepts as well. So we have two types of packaging, and we're trying to see which one is the most efficient. So remember, we have a lot of cost here. So talking about how much total packaging would be the surface area. So total packaging would be, I'll put SA. And remember, if you wanted to find the surface area of each of these figures, you'd have to add up the base and the lateral sides. So for this cube, it's not too bad. We're going to have this square right here, right? So each of these squares is 4x squared. And if you remember, a cube is going to have 6 faces. So this is going to equal 24x squared. Versus for the cylinder right here, it has two major pieces. The base, so that's a pi r squared, All right, so since it's a circle, and since we have a radius of 2, it's going to be pi x squared. And then multiply from the top. We have 2 of them, so I'm going to add those together. So we'll have 2 pi x squared, showing the bases. And then the lateral sides are going to be the circumference times the height. So the circumference, again, if the radius is x, it's 2 pi r. So it's going to be 2x, really. So 2x times the height, which is 2x. So I'm going to simplify that. So that's 2 pi x squared plus 4, I forgot a pi here, 4 pi x squared. Okay, so that's the surface area for both of those. That's a geometric concept. All right, and then the second piece is saying, well, how much, do we actually fit in those containers? Because the cost is in the packaging, but we want to see how much are going to fit. So we're going to look at the volume. So if you look at the volume of each of these packages, well, for the volume for a cube, you just have to do length times width times height, right? So 2x cubed would be 8x cubed. And then for the volume here, we're going to multiply the base times the height. And so the base, again, we figured out the area of the base was pi r squared. So pi x squared, right? And then we had 2 of those for the surface area, but just pi x squared is the base times the height, which is 2x. So that's going to be 2x cubed pi. All right, so what we're going to do is compare these packages. So I'm going to write this over here in the middle. So we're comparing the cylinder, which is 24x squared over 8x cubed. And we can simplify that. I'm going to just draw a line here so I have some room for my other one too. All right, so we can simplify that because 8 goes into 24 3 times. And then we can tell that we have one more x in the denominator. So this is going to become 3 over x for these, this prism, this rectangular box, right, the cube. And then looking at the cylinder, I'm going to do the same thing. I'm going to divide, just make some room here. We're going to divide the surface area, which is 2 pi x squared plus 4 pi x squared over 2 x cubed pi. And what I should do, actually, I'm going to add these together because they're like terms. So we have 6 pi x squared. Okay, there we go. All right, so now we can reduce this. So looking at the numbers, well, 2 goes into 6 3 times. The pi's cancel out. And then we have one more x in the bottom, so that's 3 over x. So even though they have different shapes, the proportion is still the same. So it means that the efficiency rate would be the same. So if you have x for the volume, it's going to be a ratio of 3 for the surface area. So you could say choose either one. They have the same efficiency rate. All right, so let's just make sure we look back at the topics that we've covered. All right, so again, when we're simplifying rational expressions, it's really important to consider what are the domain restrictions. And remember, that is from the denominator. You can't have, in this equation, you can't have a -1 because that would make that first fraction have a 0 in the denominator. And you can't have a 2 because that will make the second fraction have a 0 in the denominator. We can only cancel when we have common factors. So we always want to try to factor first and then reduce. And then when we have division, remember we're multiplying by the reciprocal. So we can change essentially that into a multiplication and Repeat that process, factor, and then cancel out common factors. All right, I hope this lesson was helpful, and I'll see you all in class.